All right, so what we're going to talk about today is naming compounds, whether it's ionic or covalent. What I have here is three separate problems that are going to help us identify not only how to know which rules to use, but they'll also give us a little bit of background here on how to do these things. So I'm going to start with number one here, and for number one, the first thing that we always want to do is we want to look at that first element, and we want to look at our periodic table, and I'm just going to highlight lithium, and hopefully we remember that blue line, right? Remember that the blue line really signifies, gives us a little staircase here that helps us separate the metals from the nonmetals. And so we see that lithium is in that metal section. So that tells us right away that it's ionic. So we're going to use the ionic naming rules for this. So I'm going to have you look at the reference sheet. And if we look at the top, we always want to start on these flow charts at the very, very top. So we got a formula, and it says, is the first element a metal or NH4? Well, we just figured out on the last slide that lithium is in that metal area. NH4 is kind of an exception to the rule. You notice that nitrogen is a non-metal. However, NH4 or ammonium is really just something that we've got to remember as an exception. So in this case, we're going to go down the right side because that first element is a metal. So that tells us right away that it's an ionic compound. So it just comes down to knowing your ions or looking up those ions on your ion reference sheet. We're just going to name the cation, and we're going to name the anion. So when we go to name the cation, in this case, Li stands for lithium. So when we look at the ion sheet, all of those positives, all of what comes first, or the cations as we like to call them, are going to be on this top part. So we can always look in the top section there for that first element. And there's our lithium, in case we forgot that Li stands for lithium. So I'm just going to come back here and I'm going to write that out. I'm just going to name my cation, which is lithium. All right, so now what I'm going to do is I'm going to go back to that ion sheet, and I have to figure out what is Br. Right? And some of you might know it just off of the periodic table as bromine, but when I look on that ion sheet, what I see is that the Br ion is actually bromide. So you'll notice that all of the elements that are what we call monoatomic, they're by themselves, right? There's chlorine or iodine. We change the ending of those to IDE. And that's really what it's talking about when you look at this. Name the anion. If it's a single element, it says we change the ending to IDE. If it's polyatomic, we don't change anything to the ending. We just write it as it is off of that ion sheet. But in this case, we'll stick with the fact that it is bromine. It is a single element. And so when I go to write this now, what I'm going to do is I'm going to just write the anion bromide. All right, so lithium bromide. And I wouldn't worry about capitalization. Really, in reality, our capitalization, this should be lowercase, LIBR. Our lithium should be lowercase. But really, capitalization, I wouldn't worry too much about at this level. So what's going to happen next? Let's look at number 2. So for number 2, we have copper, Cu. If I look on my ion sheet, I actually can spot copper right there. Oh, wait, but, oh, shoot, there's 2 of them. So which one do I use? And this is the last piece of really what that flow chart, when we look on here, the last piece of the flow chart, notice here it says if the cation is any of those 4, copper, iron, nickel, lead, we need to have a Roman numeral that's after the cation name. So it could be 1, 2, 3, it could even be a 4. So when I go back, how do I know what that Roman numeral is? Is it copper 1? Is it copper 2? What I really actually need to do is we need to actually put the charges back. So when we write formulas, and if you're still unsure of how to write a formula, maybe take a look at the next video on writing formulas. But really, we need to look at the charge that the copper had. So when we write an ionic formula, we do the drop and swap method. Again, watch that video if you need more on that. But what happened was that this 2 right here actually came from the fact that copper was a +2 charge. So when we actually wrote that formula, that's where that 2 came from, was actually from that charge on copper. So what I would do is I would write copper, and again I got to identify which one, and then the Roman numeral for 2 is II. So that would be correct. Now let's finish this off. What about the Cl? Well, back to the ion sheet. Cl is typically chlorine, but again, if we look on this ion sheet, chlorine by itself, our anions, we change the ending to IDE, so I would write chloride. So now, what if it were maybe one of these other polyatomics? What if it was instead something like nitrate? So here's our nitrate. We'll say it's still copper 2. Well, what that formula would look like, it would look something like this. CuNO3 parentheses with a 2. So now it's still copper 2. That doesn't change. All right, I just want to focus on naming the ending here, that anion. It's still copper 2, because again, that 2 charge came from the copper. There should be a 2 there. The anion nitrate, we don't change the ending to IDE. That's what I wanted to point out here. We just write it as is, as you actually would read it off of the ion sheet. So for ionics, it's pretty straightforward. You look up the ions on that ion sheet, and you write down what it is and identify Roman numerals if need be. Now for that next one, if I slide this up here a little bit, when we look at that first element is not a metal, right? If we go back to that periodic table and we highlight where nitrogen is, it's in the nonmetals. So now we're starting with a nonmetal. Now you got to be careful that it's not ammonium, excuse me. But in this case, if we bounce back to our reference sheet here, is our first element a metal or NH4? No. So now we're actually going to go up the left side here. We know that it's a covalent compound. And we're going to name the elements, and you're going to put the least electronegative one first. Now that'll make sense later in the year when we talk about electronegativity. For now, you can just trust that the order that we give them to you, so like for example, NO3 is already in the correct order. So we're just going to name the elements. So in this case, NO3, I'm going to name the elements nitrogen, and oxygen. So now what? Well, I need to change the ending of the second element to IDE. So instead of oxygen, we're going to get rid of the ending here, and we're going to call this oxide. Oxide. Now, a lot of times students will ask, well, how do I know what to cut off the end? And it just needs to sound correct. And really, we're not going to take off points if you were to put like oxygide, even though it just kind of sounds funny. So there's no set rule like take off the last 4 letters or the last 3 letters. But you need to have it ending in IDE and just make it sound good for now. As you get more exposure to these, to naming, you'll kind of get the hang of it. For example, we wouldn't say phosphoride. That doesn't really sound good. We would call it phosphide. So again, with practice, you'll get better at that. So the last thing we need to do with this is we need to add the proper prefixes. So the biggest thing students will do is they will confuse these two, right? There is, for ionic, we're using the ion sheet. For covalence, we use these prefixes. So we give these prefixes to you, and we use those to tell how many there are. And here's a key point right here. I'm going to highlight in yellow. Don't use mono if it's on the first element. So if I go back to my original problem, I would have to add prefixes to this. So I would have I have one nitrogen, so it would be mono is the prefix for 1. And then the prefix for 3, right, because I have 3 oxygens, is tri. So remember that one thing I highlighted on yellow on the last slide, though. We don't put mono on the first element. We're lazy chemists. Take shortcuts whenever we can. So our final answer for this then would be nitrogen trioxide. Nitrogen trioxide would be our final naming for that. So big key thing is to keep them separate, understand when we need to use the ion sheet for those metal and nonmetals, and then also when we got to use these prefixes. Don't start mixing those two together. Hopefully this was helpful.